Hey there. We're going to work another example in this lesson. Here it goes. A ski gondola in Bogus Basin Ski Resort carries skiers to the top of the mountain. Assume that it bears a plaque stating that the maximum capacity is 12 people or 2,004 pounds. That capacity will be exceeded if 12 people have weights with a mean greater than, if we take the capacity and divide it evenly among the people, 12, 167 pounds. Because men tend to weigh more than women, a worst-case scenario involves 12 passengers who are all men. Now, the National Health Survey lets us know that men have weights that are normally distributed with a mean of 172 and a standard deviation of 29 pounds. So with all of this information, we want to find the probability that 12 randomly selected men will have a mean weight that is greater than 167 pounds. And that is, we're interested in the 167 pounds because that would be the total weight that would question the maximum capacity of the gondola, which is 2,004 pounds. So I want to take a minute, sketch it out before we jump right into software. There's a lot of numbers here. Try to tease out and organize what we have here. So from those paragraphs, I saw that the mean weight of men is 172 pounds, and the standard deviation for the weights of men is 29 pounds. That was given to us from the National Health Survey. I also saw that we were looking specifically at a sample of 12 men, and we were curious that their mean weight, not an individual, but the mean weight of these 12 men would exceed 167 pounds. So I drew a bell curve to find this probability, and I knew that I could put 172 underneath the center. The mean of the population will be the mean of the sampling distribution. We saw that in some of our prior videos. Also, we know that we have to modify the standard deviation. The standard deviation of a sampling distribution of means is the population standard deviation, 29, divided by the square root of n. And in this case, n is 12. And again, with a scientific calculator, I divide that out, and my standard deviation for this situation with 12 men is now 8.4 pounds. So I gladly did the 3 equally spaced tick marks out to the edge that are each a standard deviation away. So I subtracted 8.4 2 times, 3 times over, and labeled these tick marks. I like to do this so that I have a sketch that's somewhat drawn to scale. Now, what I'm going to do now is take the sample mean that we're interested in observing and how likely it would be, which would fall right here, 167 pounds. As the mean weight of the 12 men is 167. And the problem read, or we would assume that if the mean weight is more than 167 pounds, we've got some questionable functioning of our ski gondola. So I shaded to the right. So once again, I have a nice sketch of what I'd like to accomplish in technology. So now we're going to move over to StatCrunch and see what the area of this orange shaded region is, which we realize is the same thing as the probability. Get to the normal calculator. Stat, calculators, normal. Again, just generic. Actually set up as the standard normal right now. We're going to make this apply to our situation. So we're going to put the 172 in for the mean. We do not put the 29 here. We put the 8.4 here because we're looking at samples of size 12. So again, much like when we worked with a proportion, we have to do a little work to arrive at the proper standard deviation when we're working with sampling distributions. Do greater than here, and 1 167. Mentioned this before, but notice this does not say X bar here. It just says X. This is a sort of generic normal calculator. All X means here, and in all the times we use it with proportions and such, is where are we drawing a vertical line inside of our bell curve? Where does that vertical line fall? And of course, ours fell right at the value 167. And we would like to shade to the right of it, thus we have greater than. So we get these tick marks in here. There they go. Same ones we saw. We even have the ones on the right now. And we see that that probability, or the area under the curve there, is 0.724. 724 is our probability. So that tells us that there's a 72.4% chance that the mean weight of 12 men will be greater than 167 pounds. Now this doesn't sound so promising. Seems like it's a pretty high chance, the high probability that that 12 men's weights could exceed the gondola's capabilities. Now, I'm not so sure why this is. I would guess that possibly this placard is quite old, and that, possibly the men's weights have kind of increased over the years. Not just men, but all people are mean weights and tend to have increased, whether it's females or males. So that's why I think this is quite probable. But again, we were able to find the probability of this. If it were me, I'd probably want to update that placard. I know that the capacity will probably remain at 2,004 pounds because of the engineering, but it might just mean that would mean that there would be less people. The number of people as a capacity should probably be lower. What I want to finish up with today is a simulation to kind of show you what 72.4% means, because there's a lot of percents and a lot of numbers thrown around in this class. So we're going to go back to StatCrunch again. We're going to use a slightly different feature, not the normal calculator this time. Go to Applets, Sampling Distributions. I'm going to choose a bell-shaped one. That's the normal distribution. And here I put the population information, 172 pounds and then 29 pounds. So I'm going to build a population. Notice this says population up here, and then we have choices. That's got a bell shape centered at 172 and a standard deviation of 29. So it's here for us. Seems to be reflecting that. And what I want to do is draw samples of size 12. In other words, I'm going to simulate drawing 12 men at random from a population above. So let's draw one sample and let's see what happens. So we drew 12 men out here. And what this green thing here says, this green number says mean, and it means that the mean weight of these 12 men is 180 pounds, almost 181 pounds. So that would not be too great for the gondola. The mean weight's already exceeded the 167 pounds. So as I do this, what this 72.4% means is that 72% of the time that I pull a sample out from a population such as this one, the mean weight will exceed 167 pounds. So let's try it again. 169.5 pounds. I'm focusing in here on this middle green. Too heavy for the gondola, still above. 182 pounds, almost 183 pounds, a little exceeding the gondola. So I would expect to exceed the gondola's weight more than not exceed it because of the 70% probability. 173, bye-bye gondola, it's not looking good. 192, 169, 177, so I'm on a roll here. Many of these samples are exceeding 167. 167 and a half, almost. Again, focusing in on the middle, not so concerned with what's happening down here, but just this case-by-case basis. 160, 167 77 pounds, 163 pounds. So you can see here, it took almost 10 clicks for me, or 10 samples, where finally I arrived at one that had a mean weight that would stay within the placard's request on the gondola. Now, if I do this over and over and over, it may not happen in the first 10, 20, 30 clicks, but in the long run, 70% of these samples I pull out of here will exceed the 167. And oops, so now we have another one here at 154 pounds. So we've had two samples of 13. As I do this, in the long run, we'll see that 70% of the samples will exceed. And I hope you see a tangible way to envision what the 72% means. If you have any questions, feel free to contact me. I'd love to talk about this if you're struggling with it. Thanks.